The next few videos are going to be about one of the most famous data sets in machine learning, which is a data set of handwritten digits. So let me import NumPy and pandas, and then Altair is our third most important library in this class, and then a fourth important library that we're going to use is scikit-learn. So I'm just going to import part of scikit-learn for this video. So from scikit-learn, so sklearn.datasets, I'm going to import, and then a lot of this code I'm copying from this nice book that's available for UCI students from O'Reilly called Hands-on Machine Learning. And looking at the book, the name of the function I want to import is called fetch_openml. Okay, which I'm sure stands for Open Machine Learning. Okay, that's fast. This next thing is not going to be as fast. It's going to take about a minute last time I tried. So I'm going to say the name of the data set I want to import is MNIST, or however you say it. Stands for Modified National Institute of Standards and Technologies, I believe. And then I want version 1. And I'm going to name this as MNIST with that variable name. And this will take about a minute, so I'll fast forward the video through this. Okay, that took about 40 seconds, and let's see what this did. So let's check MNIST.keys. So when you see this, you should imagine that MNIST is probably a dictionary, but it's not. If we check what it is, okay, it's some weird thing called a scikit-learn bunch. Okay, I've never heard of that before, but it behaves a lot like a dictionary. So for example, I can do MNIST, and then I can do square brackets, and then one of these keys. If, for example, data. And let me save this with, how about the variable name x? And let me check what this is. So this is a pandas data frame, and we're going to think of this as like the input data for some machine learning function we want to write. What's the output data going to be? Output data is going to come from this target. So I'm going to say y equals MNIST target. And let's check what y is. So y is a pandas series. So this MNIST is something strange, but it behaves kind of like a dictionary. But these things, these values for these keys that I've checked, they're pretty normal. Okay, one's a data frame and one is a pandas series. So we can do all the usual things we would do with an ordinary data frame. So for example, I can say, what's the shape of it? And you can see that this is quite big. So this is 70,000 rows, which is probably maybe 10 times bigger than the next biggest data frame we've worked with so far. But then especially, it's 784 columns, which is much bigger than anything we've worked with before. And if I want to see like how much space is this taking up, I can do x.info. And so I just want to point out that this is quite large. So this is taking up 418 megabytes, okay, there, which is much more than what our usual data frames take up. And what does it look like? Well, let's just check the first 5 rows of it. So very hard to tell, like, what we should be thinking from looking at this. Looks like just a very, very sparse data frame, where sparse means it's like mostly not interesting values. So in this case, it's mostly zeros. And so let me show you what kind of information is in this X. And we're going to think of each of the rows as like a sample. So each of these rows could be an input to the function we're trying to write. So let's just get the top row. So I can say x.iloc square brackets 0. And these column names, I guess I didn't even notice it when I was looking up here, but the column names are pixel 1, pixel 2, pixel 3. So that's a sign that this is some sort of image data. And let me convert this to a NumPy array. And I don't think we've used this method before, but it's pretty self-explanatory. .toNumPy, that makes it into a NumPy array. So let me call this a pre, okay, because we're going to change it in a second. So that's why I'm calling it pre. And if I look at what's the type of this, okay, NumPy array. And if I check what's the shape, okay, can you predict what this is going to be from the shape of this data frame? Well, it's just like one row from that data frame. So it's, and I could have imagined it being 1 by 784, like one row by 784 columns. But this is being treated as a one-dimensional NumPy array. So that's why there's only one dimension value listed here. So it's length 784. And the reason I called this a pre is because I'm going to name the final value a as something deriving from a pre. And I'm going to reshape this. So 784, I've gotten very used to that number because it shows up all the time in this particular data set. And the reason it shows up is because these images, they're 28 pixels by 28 pixels. And if I check what's 28 squared, we'll get 784. So we're going to get this back into the traditional shape of the image. So we're going to say reshape 28, 28. And that does what you expect. It turns it from, maybe we talked about this back in the first or second week of class. This turns it from a length 784 array into a 28 by 28 array. So this is what I'd call a two-dimensional array now. And I want to show you what the image corresponding to this array looks like. Okay, so now we can see that there are at least some non-zero values in the middle here. And I don't know any fast way to see what picture this is corresponding to using Altair. So Altair is really designed for like plotting data, whereas this is like pixel values, like pixel intensity values for an image, which I don't think Altair is really designed to do. So we're going to use the most famous visualization library in Python, which is called matplotlib. So just as an example, this is going to be the top row of pixels, and these are all going to be, I think, black in this case. And then the maximum of these values, or the maximum conceivable of these values, I believe, is 255, which would correspond to a much lighter color. Okay, like, I don't really want to say white because it's not going to show up as white, but I think white is how you should imagine it. So let me import matplotlib.pyplot as PLT. Okay, that's the traditional way to import matplotlib. And then I'm going to use, and you just have to get used to this. I'll say more about it in a different video. And one thing I don't like about matplotlib is a lot of people do things in different ways. So there are like lots of ways to accomplish the same thing. I'm going to show you the way that I like the best. Okay, and in this instance, it's a little longer than one of the other possible ways, but I think this way is like the more consistent way, so that's why I like it. So I create these things called fig for figure and ax for axes, and you're supposed to imagine that this is a figure containing one axes object, okay, which is like what we see here. And then I'm going to say ax.imshow a. So it doesn't seem like it did anything, but now if I look at the figure again, now like these are what I was referring to as the black pixels at the top, and then these yellow looking pixels, these are the light ones. And if you want to see it look more like how I think of when I see pixel intensities from 0 to 255. You can say CMAP equals, okay, and then again, a lot of this stuff I am copying, not literally everything, but a lot of this I'm copying from this hands-on machine learning book, okay, including this one. And now if I look at the figure again, okay, so or maybe it's inverted from what I was thinking. So maybe for this way of looking at it, 0 is white and then 255 is black. And so this was generated by like actual handwritten digits written by participants in this study. Okay, there are like 70,000 of these images in the original data. And so we imagine the input to the eventual function we want to write being something like this matrix or this array, or maybe better is you can think of it as like this one-dimensional pandas series as an input. And then what should the output be? Well, output should be the number corresponding to this, which in this case is 5. So if I go back to y that I got from the target column, you can see that the topmost entry in there is 5. And so if I were to do the exact same thing, so I could I'll try to do it a little faster this time. I'll call it b, and then I can say x.iloc, and let's look at this one, this second row. So .iloc2, okay, and then 2 numpy. Okay, then reshape to 2828. And let's see if I've made it this far without making a mistake. Okay, that looks pretty good. And so then instead of b here, let me say about fig2 x2 equals pyplot dot subplots. And then I'll say x2.imshow b. Okay, and then I'll display fig2 right underneath it. Okay, so this one I'd say is much clearer than the other one. Okay, this is 4. And again, if I were to look at what is the second entry in this y, in this target value, okay, then I get this, I guess it's a string rather than a number, the way it's stored here. I get this string 4. Okay, yeah, that's enough for this video. Thank you for watching.